Hi and Assalamualaikum everyone. We are from Group 3, Team 3. We are going to be presenting our assignment 1, Mathematical Function in Beam Failure. Beams are one of the most fundamental structural elements in engineering. They are designed to carry load safely by resisting bending. In this presentation, we will analyze the mathematical function of bending behavior of a simply supported beam with a point load at midspan to determine the allowable load and identify conditions that lead to failure. We have three objectives. Number 1, to determine the safe point load the simply supported beam can carry by calculating the allowable load. Number 2, to compare load cases, for example 20 kN, by plotting bending moment and identify where and when failure occurs. Number 3, to recommend design changes to mitigate beam failure and meet serviceability and safety limits.
Steel beams used in pedestrian structure are often face concentrated load. When the load exceeds limit, the beam will bend permanently and fail. In this presentation, we calculate the maximum load a beam can carry safely by analyzing its bending behavior. We will determine the factor of safety and propose design improvement that keep the structure safe. For our analysis, we use a steel beam with a length of 2 meters and rectangular cross-section measuring 0.05 meters by 0.10 meters. The allowable stress of 165 megapascal was selected. We applied the neutral axis position and calculate the second moment of area to assess the beam bending capacity. Using the allowable load formula, we determine the safe load limit and confirm whether the beam meet design requirement or not.
The moment is governed by two function formula, mx equal to px over 2 for the first region of the beam, 0 to L over 2, which shows a moment increasing linearly from 0, and mx equal to pl minus x over 2 for the second half of the region, L over 2 to L, showing a symmetrical linear decrease back to 0. To use the formula, the load F and beam length L are substituted along with the distance x. For instance, at x equal to 0.25 meter, the moment is 2,500 Newton, and at x equal to 1.25 meter, using formula 2, the moment is 7,500 Newton. Provided data table confirms the calculations highlighting the maximum bending moment Mmax of 10,000 Newton occurring precisely at the beam center x equal to 1 meter.
So for the next part, which is graph, as we can see, the x-axis represent distance in unit meter, while the y-axis represent moment in Newton unit. The structural assessment clearly indicates that the selected steel section provides adequate strength and stability under the expected loading conditions. The computed maximum moment capacity of the steel, which is 27.8 kN, is substantially greater than the estimated maximum applied moment of 10 kN. So to conclude, this large safety margin confirms that the steel section is capable of safely resisting the bending forces without approaching its failure threshold. So therefore, the structural steel can be classified as structurally reliable and fully capable of bearing the applied moment, ensuring the bearing strength.